In this tutorial, I'm going to discuss about Transit AS. Transit AS, Transit Autonomous System Number in BGP is a different scenario than what we configure in eBGP before, and then iBGP in last video, and then in this video. eBGP is a set of different autonomous system network is different networks and we are tries to configuring all that. In iBGP we create a grouping between two routers. We provide the same AS, and with that same AS, that two router become a one network, or probably not at that way, but probably it could be a two groups merging with each other, or a same group have two different headquarters. So probably that example will be great. So with that iBGP, we merge two routers with each other. We provide the same AS number. No matter the IP will be same, and no matter where we configure BGP like that, but the physicality in the real world, it will be same. Now we created iBGP, and we configure iBGP the two router, and then this router when tries to communicate with the routers, it needs to be same. It needs to have the same AS number. So for this router, AS number will be same. For this router, AS number will be same. But for this router scenario, I have to provide a different AS number, because this particular network have carrying the AS value 100, and this particular router having 200. Now with the transit AS, the scenario is a bit different. How it's different? The thing we were configuring is that this particular router wants to communicate with this router 3, wants to send some packet, wants to send some database to this router. Now, since we are seeing that the network hierarchy is the packets where we transfer from this router to this, means it will be follow the chain like this, and this particular router will have to send a packet from here to here. Basically, in the real world, ISP, internet service provider, used to do such settings so that it allows other networks packet to distribute, and probably they become a gateway. May not those packets are important for them, but they become a gateway. So for example, this router wants to exchange a data to router 3, wants to send some data, wants to receive some data. Then this particular router is a gateway for them, and for them, this for router 4, this path is very much essential. Now, what exactly we're going to do? We're going to configure a BGP and the iBGP. For this, it will become eBGP. For this router to this router will become eBGP. Then these two routers already have iBGP because their AS number is same, so always consider as one value. And this router 2 and router 3 will be eBGP. So we were trying to doing that eBGP, then iBGP, iBGP, then eBGP, and the configuration will become transit autonomous system value. Now the autonomous system numbers is same like it's evaluation of the particular routers. Now what exactly we're going to do, and what exactly the theory is. Now this particular router sending a packet to this network, and then this router will start distributing the packet. But for that, we have to not only configure IBGP, but we have to configure a protocol which consists AS number. For example, OSPF or EIGRP or any protocol which consists AS number, we have to configure those protocol in these two routers. Now, before we going to configure IBGP, we have to make sure that we have to configure EIGRP or OSPF, because if we don't configure this EIGRP or OSPF, then the advertisement value will not be distributed to the real owner or real acceptor. For example, this particular router will not receive, because if we didn't configure OSPF or EIGRP, then this particular router can send a numerous time the packets for this router will not be expected, will not able to give, or will not able to send, because these networks not enable the OSPF thing or EIGRP thing. So we have to first configure OSPF or EIGRP, and that's reason. Let me first show the router one that we configured to show IP, for example, route. Okay, now you can see that we configure OSPF, and our values were, which is sending through OSPF is, this is our connected value, and the 2.2 networks were passing with 10.10.10.2, and then 20's network was passing with the OSPF value, which is via 10.10.10.2. Now remember one thing, that our motto is only to enable OSPF, not to distribute the hello packets. So for that, we have to basically restrict that hello packets from these routers. So router 1 and router 2 will only have, or only needs to configure the OSPF, but we will not require to send a hello packet. So we have to restrict that hello packets from the network. So let me show the config T. A router OSPF. Now OSPF value was 10. Now we have to make a passive thing, so that will not allow us to send the packet. Now we'll send give a call passive interface, and we will make a passive so that it will be a one-way traffic and will not pass out those packets or not exchange those packets. So we have to do that with 00/1. Okay, Control Z. Now let me show what the command will be. Another command to find out about the neighbor. So show CDP neighbors. Now currently you can see that R2 00/0 the whole time is 1, so that it's exactly to find out the neighbor, and R4 is our neighbor, this particular neighbor, and R2 is our neighbor. So R2 and R4 is neighbor. So this is to find about the neighbors, and local interface was connected. So we just restrict the packets, restrict the hello packets from 00/1. So now these packets will not be distributed to R4 router. Okay, if you restrict 00/1, then the entire concept will go to vain, because we have to enable OSPF for two routers. Now we have to configure BGP. So let me go to configuration terminal, So router BGP value we're going to give is 100 because the AS number we configure is 100. Now neighbor IP, which is tends to and the remote AS of that router is 100. Similarly, like IBGP we were in configure before. Now neighbor now we are discussing about this neighbor, so we have to configure the neighbor. So 30.30.30.1 remote AS of that router is 300. Okay, now we configure one command is neighbor, and now we have to configure the network. So network is 1.1.0 and the mask is 255.255.255.0. we were going to give a same class C mask, the same 24-bit mask. Okay, now it's time to go to our second router. Okay, so here also we have to restrict OSPF. So router space OSPF, the value will be 10, and we have to make it passive. If you have some doubts before to understand about the concept, let me show about the show CDP neighbors. So this will show you a better picture. Now we have to block OSPF hello messages from server 0/1. So make sure that you have to value, because make sure that you blocking the right interface. Now once again we have to give the same. So router OSPF 10, then passive interface, so that it will be one-way traffic, will not be pass out. /1. Okay, so we're done with. Now what we need to do is we have to provide a neighbor value. So before what we did in the first about the first router, we blocked the OSPF hello message first, and then we configure BGP. So same we configure same with the R2 exit. Now we have to do that with the router BGP value will be 100 because same AS number they're disputing with. So neighbor, and then the value of the neighbor, the IP of the neighbor is 10.1. remote AS will be same as 100. Now again the neighbor IP 20. To 2. $200. Okay, so one neighbor is up, and similarly, now we have to provide the network IP 2.2.2.2 and the mask 255.55.55.0. Now router 3. Let me show about the show IP route. Now since this particular router is just a connect value, we have to just enable BGP, and we'll have to see what exactly whether we will exchange those packets or not, whether we're exchanging those routers or not, whatever it is. So let me configure the basic configuration. So config T router BGP, and the value which is of this AS number is 200. So 200. Now neighbor IP. Now this is neighbor we are talking about, 21. Since we're configuring at the router 3, neighbor 20 20.20.20.1. Now remote AS will be 100. Now we need to provide a network because this router 3 only have one path, 3.3.3.0 .3. Sorry, we mask. The particular neighbor is now up. Now we have to provide that mask 255.255 55.0. Okay, actually we made some mistake in R2. We exactly needs to provide a router. So let me make some changes here. Router BGP 100. The network value we want to provide was 2.2.2.0, and then the mask will be 255.255.255.0. So exactly it was this and not this 2.2.2. We actually provided an IP, but we need to provide the range. Okay, so just exit from here. Now it's now time to configure the router flow. Enable config T. Same. If you provide a show IP route, nothing will be available. Sorry. Providers do show IP interface brief. So currently the ranges we're talking about now. Do show IP route. So currently it's connected to routes, and nothing. We not enable the BGP yet. So with this router BGP the value was 300, neighbor IP 30.30.30.2, remote AS is 100, network, now time to configure network 4.4.4.0, mask 255.55.55.0. Now, one thing I would like to show you, we took some time to do that, like show IP BGP. Currently, everything is nil because it would took some time. But for example, we used to do read exactly our mode was. Now, what if configuration is all done or set, then this IP will this particular router will able to ping with this router, and this particular router will ping with this router. Okay, so we exactly needs to ping with this router ID, the 4.4.4.4, which is the loopback IP we're talking about. Now, one thing is there. This is the router. This is the IP of the interface, and this is the IP of the loopback, which is a virtual IP. Now, if we ping with this IP with this, then will not, because we nowhere configure these particular router in the routers. We nowhere configure protocol. We nowhere configuring routing for these IPs. We nowhere configure OSPF or EIGRP for these IPs. So basically, we're not allowing the router. We did configure 10, then 30, and then these values, but not configure about these even in the router itself. So routing is not enabled. Hence, these IPs have no particular values. Now let me show about the. Now we have to make sure our router 3, router 4, and router 2. So let me change this. Router 2 is okay, and router 1 is okay. Now we have to. You can see the neighbor is up, so let me give a command to show IP route. Now you can see the BGP is configured for router 4. The values which are now available: 1.1.1.0, 2.2.0, 3.3.0, and 4.4.0. Now these are loopbacks, and this is 4.0 of this router, and everything is configured via BGP. All the IPs are available, but we're trying to ping with 3. For example, 3.3.3.3. You will find that the network is aborted because 4 is nowhere configured, 3 is nowhere configured, so success rate is 0. But when we ping with router 3 by calling 3.3.3, and we tries to provide a source value is 4.4.4, then success rate is 100. You can see. So our practice is done. We successfully configured transit AS, and you can see why, because this particular ID is able to ping with this ID, and this particular ID will ping with this ID. Let me show the router 3. Control Z, show IP route. So you can see in the database BGP is now configured, and all the values, all the IPs are now available. You can also provide a command called show IP BGP. Now with this you can able to get about the IP, network IP, and the hop address. You can see that 3 is our own, but when you're talking about the 1.1.1.0, you will find that the next hop address is this 2.2.2.0. next hop is this 4.4.4.0. next hop is this. Means this particular 20 networks is advertising these IPs, the collections of IPs, and to router 3. Now if router 3 wants to ping with 4, then 4.4.4.4, then source address will be 3.3.3.3, and it will able to ping with the routers, and the success rate will be 5 out of 5. Now same with router 1, router 4. Let me show what exactly we're talking about show IP BGP. Is a entire currently is probably may not be, yes, okay, yes. So then show IP BGP command, we're seeing that this router particular have a database of the network 1.1.1 and is distributing from 30.30.30.2. 2.2.2.0 is distributing from 30.30.30.2. This particular IP is also distributing for 30.30.2. Means that these loopbacks IPs are able to distribute to router 4 to router 3, router 3 to router 4. Exactly the tables we are saw in the BGP, and because this table is there, be able to distribute the packet, be able to provide the packet, and because these logically the tables, the distribution will be enabled. That's the reason we'll find out that packets were able to distribute. So what exactly we did, we just configure IBGP, then any protocol which consists of AS number, either is OSPF or either it's EIGRP, and then we configure neighbor, then we configure network via EBGP, and this particular router we're able to distribute packet to this router, this particular router we're able to send the packet to this router. So hope you learned something about transit AS number in this video, and we configure EBGP, IBGP simultaneously. Hope you learned something from this long video. Thanks for watching.